Alright guys, today we're going to do section 12-5, angle relationships in circles. Our objectives: to find the measure of angles formed by lines that intersect circles. Use angle measures to solve problems. Okay. Let's go back here for a second. Oh, that's part of your DMR, so let's just ignore this right now. And let's move on to the theorem. First theorem for today's lesson. If a tangent, your tangent, remember, intersects the circle in one point, so BC is your tangent there. If a tangent and a secant or chord, your secant is your BA. Remember, a secant is the line that extends on a chord endpoints on the circle. So if a tangent and a secant intersect on a circle at the point of tangency, which is point B, then the measure of the angle formed is half the measure of the intercepted arc. So what that is saying is the measurement of angle ABC is half of the intercepted arc AB. And that's your theorem right here. Okay, so let's see if we can apply this. Find the measure of EFH. EFH, which is this right here, okay, and the intercepting arc would be FH, okay, and the reason why we can do that is because your point of tangency right here is point F. So the measurement of angle EFH equals half the measure of arc FH. So it's half of 130, which is, what, 65 degrees? 65 degrees. Okay? Okay, find each measure. Arc GF. GF is this right here. Okay? So measurement of angle G, which is this right here, is half of the intercepted arc. So do we know the measure of angle G? Well, the measure of angle G has to be 180 minus the 122 because you have a straight edge here. So the measurement of angle G is going to be 180 minus 122. Which is going to give you 58 degrees. And then you can multiply both sides by the reciprocal of 1/2, which is 2. Therefore, the measurement of arc GF is going to be 116 degrees. Okay, angle STU. STU is right here. And your point of tangency is point T. The intercepting arc is ST. So the measurement of angle STU is half of the arc, measurement of arc ST. Well, measurement of the arc is given, 166, so take half of that, and you get the measurement, you get the measurement of STU, of that angle. Okay? Alright, another theorem. If two secants or chords intersect in the interior of a circle, so you have chord AC and chord AD, they intersect right here at point E, then the measure of each angle formed is half the sum of the measures of its intersecting arcs. So, this measurement right here is going to be half of arc AB plus arc CD. Okay? So, find each measure angle AEB. AEB is this right here. Alright, so we have two chords. They intersect in the center, or they intersect inside the circle. So we can use the theorem we just talked about. So the measurement of this angle is going to be half of the sum of these two intercepting arcs. So there's your theorem. Let's substitute in what we know. Arc AB measurement is 139 degrees. Arc CD AD measurement is 113. Take the sum of those, divide by 2, and you get your angle measure of 126 degrees. Okay, find each angle measure, ABD. I'm going to be quiet and let y'all do this one on your own. If you get stuck, look at the board. Okay. If a tangent and a secant two tangents are two secants. Okay, here's your tangent, intersects in one point. Here's your secant, goes through. Here's two tangents, intersects in one point. And then here's two secants. Okay, so if you have a tangent and a secant, two tangents or two secants, intersect in the exterior of a circle, then the measure of the angle formed is half the difference. Okay, so if the angle is exterior, it's half the difference of the intercepting arc measurements, okay? So this measurement would be measurement of AD, subtract BD, and take half of it. So let's apply this. Okay, so we're trying to find the value of x, and that is the measurement of that exterior angle. So what we can do is we can take 87, subtract 7, and then take half of that, and we'll get the measurement of that degree of that angle, which is 40 degrees. Okay, same with b. We're trying to find x, which is the measurement of that exterior angle. So we can take 200 minus 74, and then take half of that to find that exterior angle measurement, which is 63 degrees. All right. Now we're giving the exterior angle measure, but we're missing one of the measure of the arcs. So you're going to use the same theorem, substitute in what we know. So we're going to substitute in for our exterior angle. We're going to substitute in for our arc, measurement of arc JN, and then we're going to substitute x for the unknown. All right, you can solve it like an equation. I like to go ahead and get rid of this instead of distributing. If you're going to distribute that, you're going to have 25 equals, let's see, if you do it the way they did it, you can just, to get rid of 1/2, multiply by its reciprocal, and that's what they did. This is what was inside parentheses, and they took 25 and times 2, okay? So you're solving for x. Over here, you would have to subtract out the 41.5. So let's see, what is that? 41.5 minus 25. So 16.5 equals a negative 1/2 x. And then we got to multiply it by its reciprocal, which is going to be a negative 2 over 1. So that gives me what? And this is a negative, positive 33 degrees. Yeah, gives me the same thing. Okay? Alrighty. So we're trying to find this exterior measurement right here. And what's given is arc FH, which is this, is 108 degrees. And arc LJ, which is this right here, is 12 degrees. So we can use the theorem we just talked about. Substitute in what you know. Simplify. And you're going to get 48 degrees. Okay, we're trying to find the exterior angle right here. This is applying this in real-world situations, such as an eye doctor. Arc AEB is given as 225, so we need to know what arc AB is. So we're going to use our same theorem. And to get 135 for arc AB, they just took 360 and minus the 225. And then simplify. And we get 45. All right, angle relationships in circles. So this is nothing new. This is just put it all together. When you have it on the circle, it's an inscribed angle. Okay, so the measurement of angle 1 is half of the intercepting arc. When it is inside the circle, it is where you take the sum of the two intercepting arcs and take half. And when the angle is outside, exterior, you take the difference of the two intercepting arcs and take half. And we got two more here. Let me check on time, class. All right, we're going to do one, and then the last one might do a candy question here. Okay, so we're trying to find y, arc YZ, which is this right here. Okay, so step 1 says you need to find arc UY. UY is this right here. Okay. Therefore, you're going to take the sum of the two arcs, then take half of that. So we're given So then the arc of UY is 66 degrees. Step 2, so this right here is 66. Step 2 is we need to find YZ. Which is what it's asking for here. So you can use the exterior angle. Now we got the exterior angle and one of the intercepting arcs and substitute in. The measure of that missing arc is going to be 164 degrees. Okay, that last one we're going to leave as a candy question. And make sure you let me know in class so I don't forget. And good luck with it.